Hello world from Austria. It's really amazing to have you all here. My name is Katherine Munro, and I'm thrilled to present some of my Women in AI colleagues today. First of all, we have Verena Stanzl, a little introduction to her. So after graduation, Verena started her career as a data scientist, and she now drives the digitalization in manufacturing. So she has an academic background in maths and biomedical engineering, and contributes on an interdisciplinary spectrum of knowledge to bring AI into production. So she specializes in production systems, and at Women in AI, she is our content lead for WAI Upper Austria. So she gathers expertise within the community, and she's going to present the first publication that we made about can AI solve my business problem. This was published recently to give decision makers and data scientists an easy tool for making appropriate decisions around AI. So without further ado, Verena, welcome to the stage.
Thank you, Katherine, for the introduction. Artificial intelligence and machine learning is gaining more importance in our daily lives. Think about chatbots, think about the personal recommendation systems when you're doing online shopping, when you're streaming media, but also in other parts like smart homes, smart cities, smart manufacturing. So AI is gaining more and more importance in our daily lives. And also many more and more decision makers are thinking about integrating AI solutions into their businesses. So today in my talk, we want to explore the requirements for making AI projects successful. So my name is Verena Stanzl. I'm a data scientist in the manufacturing and part of Women in AI Upper Austria. So, and as Katherine already said, this talk is based on a publication we did in our Y team Upper Austria. And you can see a nice photo of our group on the right. So you see Katherine, Julia, and me. Yes, and Upper Austria is a region in the middle of Vienna and Munich. And it's a hotspot for industry, for technology and innovations. And we observe also here more and more business makers are thinking about integrating AI into their systems. So let's dive right into, can AI solve my business problem? Designed an infographics, which you can see here on the right. And it might seem a little bit complicated at the first sight, but it can be basically divided into 3 steps. So the first one is define your business problem. The second is get an appropriate data set. And the third one is choose a suitable method. We will get through all these steps in the following. So do you have a well-defined business problem? For a well-defined business problem, it's not only important to know where do you want to go, but it's also important to know the available data set and the desired output. So what do you want to gain out of your data, and what information do you want to get out of it? It's also very important to have a plan for testing your solution, for monitoring your solution, and also for improving. It's afterwards, you need a plan on how to deploy your solution and also how to get the best out of this outcome. It doesn't make any sense to have a perfectly designed model with 99% accuracy if you don't have a plan how the rest of your company can use this output. So what is next in a data-driven solution? Of course, the data. So there are some aspects you have to consider concerning data and data quality. The first one is to have enough data of good quality. Having enough data is depends on the method you want to use and also on the topic you're into. So, but there are some rule of thumbs. Data amount is not measured in terms of gigabyte, but in terms of data points. For example, if you have a web shop and you have 100 customers with 10 purchases each, you have 100 samples and 1,000 data points. That may seem quite a decent amount, and it's for sure enough for doing some basic statistics, but it's way too less for other machine learning, for other techniques like machine learning. Another common and really important aspect is the problem represented in the data? So is it actually there? You cannot get information out of your data where you don't see the properties of it. So, for example, if you want to predict machine failure or tool failure, you must have a data set where a tool or a machine failed several times. Because your domain experts, they might give you hints about the parameters which influence the process, but you cannot be sure, and you cannot predict events where you don't know with which parameters they come with. And another aspect is to analyze that the problem has to be it has to be possible to analyze the problem isolatedly, so it doesn't have interference from other external sources you cannot control. We have seen this recently during the COVID pandemic outbreak, where markets really changed. Because in a stable market, you have stable predictors for your sales predictions. But as soon as the market changes or a new competitor enters the market changes, and also your models might not go along with the new situation anymore. As I already said, that was during the COVID outbreak, where a lot of machine learning models failed in predicting future events as the market completely changed. So have to in mind that the problem has to be analyzed isolatedly. What do you do if you don't have the data, or if it's too less, or it's of pure quality, or it doesn't represent the problem at hand? Get more. So you have three possibilities. You can create your own first-party data from a web shop or from an active machine. You can also use open data from public sources or research institutions, or you can also buy third-party data sets. There are some known companies who are selling their collecting data, so this is also, of course, a possibility for you. Keep in mind that the data acquisition and the data quality is really essential, because it can make or break your project. It can make or break your project, and it might have the highest cost of the project. So it's really essential to do the data acquisition and the data quality inspection to make this step good. So now we have the basic requirements. We have a well-defined business problem. We have a good data set, which has enough data points and is of good quality. So now we can talk about some methods. But the first question you have to ask, is a learning system even necessary? Because why should we put a lot of time and effort and money into the developing of a system when there is a much simpler solution? And the answer to this question is divided into 3 steps. So the first part is the induction versus deduction part. The science-prone reader listeners know what I mean here. So basically, it depends if you want to test a hypothesis or you want to find hidden patterns in your data. The second aspect is on how does the data emerge? Do you have static data, or do you have a continuous data flow? And the third aspect is the frequency of the analysis. How often do you want to analyze your data? So, for example, if you know that you can model your problem with underlying, for example, physical principles, you know it from literature how to do it. You did experiments on how to do it, and you can basically derive your parameters by solving some equation system. Then you don't have to learn the parameters, and you can go straight into mathematical modeling. Or if you already have a suspicion which parameters influence your outcomes, so you have a clue which parameters might differ or what influences your outcome, then you can go, then statistical hypothesis testing has all the tools you need to test, and you don't need to learn anything. Or if you have a continuous data stream, maybe from an active machine, and you want to automate this statistical analysis, and the parameters stay the same, then you can do just scripting and run the scripts and do this basic analytics. On the other hand, if you don't have a hypothesis in mind, and you have an ongoing data emerge and want to find hidden patterns in the data, or you have this repeated analysis, but the parameters change as soon as new data arrives, then machine learning becomes interesting. Welcome on the AI machine learning side. The first question a data scientist will ask you is, do you have labeled data? So what is labeled data actually? Labeled data is a sample or data with an additional information or some kind of tag. So the commonplace example would be images with cats and dogs on it, where you have the label cat and the label dog. But for example, for a music sequence, that would be information about the music style. Is it pop? Is it rock? Is it jazz? Or in industry, for the process data of a component, this would be the information about the quality. Was this component okay? Has it a kind of defect? Which kind of defect has it? Or for a product in sales or in marketing, you would have a tag for the number of sold items. What do we do if we don't have labels? Well, then we should consider to label our data. Why? Because many more machine learning options are then available for you. We can make more machine learning methods possible. For example, if you don't have labeled data, you can for sure discover classes by grouping them into similar properties, as it is shown here on the right. And an algorithm can learn this segmentation for you. So you have this data points grouped, but the interpretation of these clusters needs domain knowledge. So the algorithm doesn't tell you that these are oranges, apples, and strawberries. So you need your knowledge to classify them on the properties you see. If we have labels, then the world of machine learning is open for you. Here are some examples which methods we can use. So for example, if we want to predict quantity, like how often will the product sell, or the remaining useful life of a machine, or how much energy consumption will there be in the next month, then we can use a method from regression. But if we want to predict future events, like when does a machine fail or when does a customer churn, then this is a time series forecast. And if we want to detect which kind of defect a component has, a classification method will do. So yeah, now we talked a lot about machine learning, but everyone is talking about deep learning and neural networks, artificial intelligence. What about deep learning? So the basic difference between machine learning and deep learning is that in machine learning, an algorithm tries to find patterns by using statistics on the features or properties you give the algorithm with the input data. So the data scientist needs to extract features, to design these features so that the algorithm can find the underlying patterns in it. So most of the time for machine learning goes into feature engineering, feature designing, and validating these features, experimenting with that. And so we iteratively improve the model. Whereas in deep learning is a subgroup from machine learning using deep neural networks. So we have an input layer and an output layer, and in between some interconnecting layers. And during training, the parameters of these interconnecting layers, they improve and change, so that a certain input pattern always leads to a certain output pattern. And during this training, these neurons, these are the so-called elements of these layers, they adapt themselves in such a way that they learn the input features they need to do their task. So a data scientist won't do as much feature engineering as it would in machine learning, but the data scientist needs to have expertise on the different architectures, on which architecture to use, how to tune the parameter, how to get the best out of your model. So more effort is going into the architectures and designing architectures, testing the solution, and so on. As deep learning as the neural networks are identifying the features to solve the task by themselves, they need much more data and all that things that come with them. So we need a lot more time for preparing the data, much more computational power. It also comes with more costs for computational resources. So that are all things you have to keep in mind when calculating developing costs. So when do we use machine learning and when do we use deep learning? So deep learning comes interesting, especially if the problem is too complex for machine learning. So the underlying patterns are high and relationships are highly nonlinear and too complex for machine learning, then you can try deep learning. Especially also if you know there are underlying structures and relationships, but it's hard to quantify them in terms of features, then also deep learning might be interesting for you. On the other hand, if you need to interpret your model, you have to know why the model is taking a certain decision, then you might stick to machine learning. Explainability in deep learning is an active field of research, and there are more and more insights coming out. But the methods for machine learning and for interpreting machine learning models is much more advanced. So if your decisions have really driving consequences for human lives, or you have to explain the model to your stakeholders so they are willing to integrate the system, then you might stick to machine learning and put your effort into explaining these models. So that seems nice. Machine learning is solving your tasks. Deep learning is searching the features themselves. So it seems like it's the universal solution for everything. But are there also risks when using AI? AI and machine learning and deep learning is gaining the information from the data you provide. So especially if you're working with data about humans, make sure that the data is diverse enough. So consider whether all genders are represented, whether all ages are represented, and also all ethnics are represented. Otherwise, you have bias in your data, and some people might be discriminated against your system. When working with personal data, you also have to consider the extent on how you have to anonymize your data. Otherwise, you might reveal identity. And this might not only lead to unfair treatment of people, but also to legal problems. So keep that in mind. Yeah, machine learning is not errorless. So of course, there might appear errors or misinterpretation, because correlation doesn't mean always causality. So there can also be other influencing parameters behind. So the errors in your machine learning system might lead to loss of money, loss of time, and also loss of reputation. So keep that in mind. Yeah, and then we are going to the conclusion. So the main parts are have a plan for your input and what should happen with the output. So know what your data is, what is in the data, what your data represents, and also have a plan what should happen with the output of the model. If you're talking about data, keep an eye on your data set. So the problem should be represented in the data. You should have enough data. The quality should be okay, and be sure that the data set is diverse and nobody can be discriminated against it. And another message of this talk is go for the simplest solution. So when there is a solution which is simple, then just pick the simple solution. For machine learning has really great potential and also has in some tasks, like in computer vision, already outperformed humans. So just keep in mind which method you should use. It should not be the question should not be asked like, can AI solve my business problem? The question should be, which method can solve my business problem? Can AI or machine learning help to solve my business problem?
Wonderful.
So, yeah, just another notice. Have a look at our article. So this is just a teaser for our article. Just search for Medium publication, Can Artificial Intelligence Solve My Business Problem? And you will find it. There you also find our infographics, which just explains and summarizes the talk in this graph. So yeah, thank you for listening.
Perfect. Thank you, Verena. Sorry to cut you off there. I'm just very excited about this topic. Absolutely check out our infographic. And I have time for one quick question from the audience. So as a data scientist myself as well, I know that people often underestimate how much of the work involved in preparing a machine learning model is the feature engineering. So choose, for anyone who's maybe not a data scientist in the audience, that means choosing the right attributes of the information to feed a model. Do you have any tips on how that can be done, or any common libraries or things that can be used for feature engineering?
If you're using Python, there are a lot of machine learning and data preparation libraries out there. So check out Pandas. With Pandas, you can also create some simple charts to explore your data to see where there might be interesting features or correlations in it. Then in scikit-learn, there's also a lot of pre-processing in it where you can just scale and standardize your data. So this is also a library you should check out. For time series data, if you want to extract features from time series, then tsfresh might be interesting for you. There you can just, with some lines of code, you can extract lots of features, which might be interesting. Yes, so that are the first libraries I would go for when using Python.
Okay, fantastic. So just to summarize there, Pandas, scikit-learn, and tsfresh. And I believe also that packages like R can offer some feature importances so that you can train a model and see what was perhaps not so useful and then get rid of that feature for future. Would you agree there?
Yes, for sure.
Okay.
But I'm not so familiar with R, but there are for sure libraries out there to use.
Yes, I think that's that one's definitely for the statisticians out there. Okay, while we prepare for our next guest, then I will just throw in one more question myself. Have you had the experience that a lot of businesses underestimate how much data they require, and also the time that it would take them to prepare that data if they need to annotate it themselves?
Yeah, annotating data needs more time than you can think of before, because you have to label each data point by hand. But there are a lot of tools out there which help you with this process. You can just search for them. But yes, sometimes businesses underestimate how much data you really need and that this data has to be comparable. So it's not enough to have data and to have gigabytes of data. You also need to have samples which you can compare. So the processes have to be stable. for example, if you get your data from production, then you also should be sure that the process engineers don't experiment with the data, so the samples getting comparable. And if they do, this should be documented. So and this is sometimes underestimated, I guess. Yeah.
Yes, that's right. I've heard of entire experiments being ruined because somebody made some changes to the data and that wasn't tracked properly. And yeah, okay, so this is really important.
And then you're wondering what happened with the data.
Yes. Okay. Yes. Perfect. Well, thanks so much for that. Everybody in the chat, you will see there was a link posted to our article. So please do go and check it out and give us a little clap. Somebody asked if Verena is able to share her slides. I know that Verena has a Medium account, Verena Stanzl, so perhaps she is able to share an article based on those slides there.
Mm-hmm. For sure.
Okay.
Yeah, I will check that out.
Okay. Perfect. Then. Thank you so much for your time, Verena. Thank you, everyone, for listening. And we are now ready to introduce Gabrielle. I'll just check that she is here.